All right, good day, children. We are going to be studying percent increase and decrease. Most of the examples we'll be using today will have to do with money, but we're also going to apply it in everyday situations. Now, in class or online, you'll be handed a list of problem cards, and there's about 10 of them. Each one is a different scenario explaining some kind of change in percent. And all of it's based in things that do happen in real life. And today I'm going to explain to you how you're going to set these up and work through some of them. Whatever ones I don't do, you will be responsible for doing the remainder. So let's go ahead and start now. Our first card here says, a pair of sandals is on sale for 20% off the original price. If the original price of the sandals is $21, what is the sale price? Now, if you look at the card itself here on the screen, you see that we have 1, 2, 3, 4, 5 different choices, and then we have these little responses also. Well, these responses are all going to be used at the very end of this whole lesson to make a paragraph that says something. So you won't be needing these until the very end. But right now, let's go ahead and look at our choices, and let's go ahead and look at our problem here. So we have a pair of sandals that are going on sale for 20% off. We want to know what will the new price be, or the sale price, if they were originally at $21. So let's go ahead and explore that now. Now what I have here is a copy of the problem on some paper. You will be receiving something similar to this to work your problems on. And I'm going to go ahead and show you and demonstrate how you will approach these kinds of problems. First of all, what we want to do is go back to the bar diagram. It is very, very useful for all these types of problems. And I have a ruler here, but you can go ahead and use your ID. And you don't have to make a bar that's quite so as big, but I'm doing this just for effect. Now, we know that when we have a bar diagram, it represents everything from 0% all the way up to 100%. And then in this case, we have the other thing being measured is the price of the sandals in dollars. So if we have 0% of sandals that are purchased, then we have $0 that are spent. And conversely, we know that if we have 100% of the price of the sandals would be $21. So there's my bar, and it's labeled percent on the left and then the dollars in this case on the right. Now we know that there is a sale for 20% off. 20% off means then that my price and everything is going to decrease. So I'm going to go ahead and use a red arrow here to show that we have a 20% off drop. Alright, so now everything falls down with it, and we have a new percent, and we're going to have a new price. Well, if we were at 100% and we dropped 20%, that means we are now at 80%. But what we don't know, though, is if the full price, which is $21, what is the new price? So we'll call that X. Now all we need to do is make a proportion like we've been practicing for the last few weeks, or for the last week or so, and go ahead and solve this. So here's how we're going to do it. You see the numbers, how I have them set up here on the left and on the right? I can use those exact numbers in that exact same order to solve this proportion. I would write 100% over 80% equals, and I keep the other numbers the same exact way, $21 over X dollars. $21 over X, or the unknown amount of dollars. Now what I need to do is go ahead and cross multiply and divide. What I'm going to do is I'm going to show you a more correct algebraic way to solve this. So cross multiplying still happens. I'm going to have 80 times 21. So over here on the right, I'll go ahead and parentheses put 80 times 21. But since this is a proportion, that means these two things are still equal. So what is it equal to? And I'm going to show it's the other two things that are being cross multiplied. In this case, the 100 times X. So 100 times X. And you can go ahead and see how I wrote my equation now. This times this equals this times this. Now we go ahead and do the math. The only math I can do right now is this 80 times 21. When I multiply 80 times 21, I get 1,680. My equal sign drops down. 100 times my mystery number x is just 100 times whatever x is. So I'll just write it as 100x. But I don't care what 100x's are. I want to know what is just 1x. What is my mystery price? In order to do that, I'm going to have to get x all by itself. Since x is being multiplied by 100, I will have to divide by 100. And whatever I do on one side of my equation, I have to do to the other side of the equation. So I'll divide this side by 100 as well. Now I go ahead and continue solving. 100 divided by 100, well, 100 goes into itself one whole time with x left over, so I have 1x. I have that x all by itself just like I wanted. The 100 divided by 100 went into itself one time. 1680 divided by 100, well, there's a little trick. If you know where the decimal is in a number and you're dividing by 100, you move your decimal left 2 times. In this case, 1, 2. So my answer will now be 16.80. All right, so that is my new sale price. My new sale price is $16.80, and I'll go ahead and write down the bottom. The sale price is $16.80. Don't forget that you have a decimal point when it's between the 6 and the 8, but it's a it's a period at the end of the sentence because we are writing a complete sentence. So get used to reading that and writing that. Let me try to make it a little clearer for you guys. There we go. So there's the first problem. If you have any questions, please pause the video and raise your hand. If not, we'll go ahead and move on to the next question. Looking back at our choices, we see that $16.80 happens here at choice B. So when we start putting together our little story, we know that for problem number 1, we're going to have Miss Clark, which is associated with the right answer, 16.80, to be filled into this answer sheet. Let's go ahead now and look at our next example. Our second example now is about Max. It says Max wants to buy a new DVD player for $89.75. If sales tax is 8%, how much will he pay in total for the DVD player? So this problem is very similar, with just the opposite effect now. So to work on this one, let's go ahead and, just like last time, let's go ahead and create our bar diagram. I'll use my ruler over here. Let's go ahead and get the other side. Hopefully you guys will be a lot faster. I'm sorry to bore you with the actual drawing of the diagram. It would have taken too much time to make all these pages in advance. So we know we always have from 0 to 100%. That's always easy to do. And then in this case, we know that the total price of the DVD player is, well, not the total price, the original price is $89.75. That's the 100%. So $89.75. We also know if we have 0%, then we spend $0. Now, it says if sales tax is 8%, how much will he pay in total for the DVD player? When you have sales tax, that makes the price of things go up. Taxes make you pay more because you're paying for different items, or you're paying for different services attached to those items. So we're going to pay an additional 8%, which means we're going to go from 100%, we're going to go up 8%. Well, if we went up 8%, then that takes us to a total of 108%. So I'll go ahead and have to mark that now. So I have here 108% because that's going to be the new price when I pay taxes. But what I don't know is the actual amount in dollars that's going to be. So I'll call that X. But already I can see my proportion taking shape. I can go ahead now and set it up. I'm going to say 108 over 100. I'll write it over here, is equal to, because this proportion bar shows us how they're equal, to X over $89.75. X over $89.75. For now, in the beginning, I'll put my units, and then I'm kind of going to go ahead and leave them off until I finish doing all the math. Now I begin to cross multiply and divide just like I did in the previous problem. Let me go ahead and move my paper up so you can see the work. I'm going to cross multiply 100 times x. So in parentheses, I have 100 times x, you see right there. Then I'm going to multiply, 108% times the $89.75. So since they're proportional, that means they're equal. 108, it's like my pen's dying there. Let me go ahead and switch it out. 108% times the $89.75. Notice I left the units off. There's no point in writing the units for right now. Later on they will be important, but not for this lesson. Now I go ahead and just finish up multiplying everything. 100 times x is 100x. I don't know what x is, so I can't go any further with that part, but I can do the 108 times 89.75. I did do this math in advance, and I get 9,693. Now, I know that 100 x's, or 100 times x, equals 9,693, but I want to know just what a single x equals. So I will divide both sides of my equation by 100. When I do that, I get 100 divided by 100 is 1x. So I have a single x left over. That's exactly what I want. 9,693 divided by 100 means I take my decimal, which is over here invisible at the end, and I move it to the left twice. Once, twice, and I end up with 96.93. But what does this number mean? That means the total he will pay, oops, excuse me, let me scratch that down, start over again. He will pay, there we go, the total he will pay is $96.93. And if I look at my answer choices, I see that it's going to be choice A. The word associated with that is the word shocked. So when I do my MathLibs answer document, I will write the word shocked for problem number 2. If there's any questions about this problem, please raise your hand. If not, we'll be moving on to the next problem. Now that we've finished problem number 2, I will leave you to do problem number 3, which is done just like one of the previous 2 problems. You'll do that on your own on a separate document. I'm going to go ahead and move on to example 4 now. Example 4 says, a $129 golf club is on sale for 30% off. If sales tax is 6.25%, what will be the final cost of the golf club with the discount and sales tax? So what we have now are 2 separate things happening at the same time. And this is more like real life, because a lot of times you'll see sales, but we always have tax to pay. So back here to number 4, a $129 golf club. Now, it is on sale for 30% off. So the first thing we want to do, like always, is make our bar diagram. Since we have 2 things happening, I will end up having 2 bars. So I'm going to make this one a little more narrow than the previous ones that I did before. So let me go ahead and construct this real quick, just like you'll be doing on your paper. As always, we go from 0% to 100%. And since we're measuring money, $0 to the full price of $129. Now it says that it's on sale for 30% off, which means we're going to have a decrease in price. So I'll go ahead and just estimate wherever that I think that might be. And it is 30% drop. So I need to find the new percent and my new amount of money. Well, I know that if I have 100% and I go down by 30%, then that's going to be 70%. But what I don't know is the amount of money that that's going to be equal to. So like before, I'm going to go ahead and set up my proportion and cross multiply and divide. And I'll do that underneath my bar just for the sake of preserving some space. So I have 100 over 70 equals 129 over x. Let me put my units, and then I will attach them again at the very end. Cross multiply 70 times 129, I'll put that in parentheses first, equals, because it is proportional, 100 times x. Sorry for my sloppy writing. I'm trying to make this a little faster, since it's the same process over and over and over again. So now we have to go ahead and multiply 70 times 129, and we get 9,030. Then we go ahead and do 100 times x, which is just 100x. I will then go ahead and divide both sides by 100. I'm running out of space. Hopefully you guys will have a little more space when you do yours. And I'm going to go ahead and do the math really quick. 100 divided by 100 is 1x. So I'll write my number right here. Here's my x. And 9,030 divided by 100, I move the decimal from the end twice to the left. And that means that my new price is $90.30. So that's my price just with the first 30% discount that was taken. And I see that none of those answers correspond because I am not done yet. On top of that, now I have to add the sales tax, which is going to make my price increase. So I'm going to go ahead and model that now with a second bar. I'll go ahead and make this one a little shorter. Just once again so I can save space. I don't have the same issue that I just did with the previous part. Label it really quick, 0% to 100%. And then from $0. Now the new full price is $90.30 because that's with my 30% discount. However, I have to apply the tax, and tax makes prices go up. My tax is going to increase at 6.25%. So that's how much it increased by. Well, I need to figure out how much that's going to equal in money, which I don't know, but I know what that does equal in percent. 100% plus 6.25 is 106.25%. There you go. I'll kind of zoom in so you can see it. It's a little small because I'm trying to make it all fit. 106.25% because we increased by adding the sales tax. So my proportion's pretty much obviously set up for me, and I'll go ahead and start working it out. 106.25 over 100. That's going to be the left-hand side. Equals x over $90.30. X dollars over $90.30. I forgot my percents over here. There we go. Now let's go ahead and cross multiply. 100 times x is equal to 106.25 times 90.30. All right, let's go ahead and multiply it out. 100 times x, we just know that's going to be 100x. 106.25 times 90.3 or 0.30 equals 9,594.375. And just as we did in the previous problems, we don't want 100x, we want just a single x. So I'll divide both sides of my equation by 100. I do that quite a bit, it seems like, in these problems. 100 divided by 100 is a single x, or 1x. And then, using my trick from before, dividing by 100 causes my decimal in the number above to move 2 spaces to the left. So I end up with 95.94375. But since we're talking about money, I know money only goes to 2 decimal places. And I look and I consult my little rule for rounding. When I'm rounding, I look at the number after where I'm rounding. Will this 3 affect the 4? And since the number has to be 5 or higher, then no, it will not. So I can go ahead and just cut all this off that comes after it. And my answer is $95.94, or $95.94. We see that here for choice C. So I'll go ahead and write it out. The final price is $95.94. There we go. Very easy to write out. If you have any questions about this particular problem, please raise your hand. If not, we'll be moving on to the next one momentarily. Now that we've finished with number 4, we will go ahead and just scroll past number 5 because that's going to be one that you're going to do on your own. And let's go ahead and look at number 6. Number 6 says, Alex is buying a sweater that originally cost $35 and a pair of jeans that originally cost $28. If the sweater is marked down 30% and the jeans are marked down 15%, find the total cost, including the 8% sales tax. So we have 2 things happening. This is a pretty detailed problem, so I'm going to go ahead and do my work in the same fashion I did before, but I'm going to use the space on the side that I have over here of the problems to make my percent bars. And I'm going to make them pretty lean so I can fit in all the information. So I'll make one over here. And the reason why I'm doing 2% bars is because the problem mentions that we have both a sweater and a pair of jeans that are being purchased. And there are also not only two items, but they're both being affected in two different ways. The sweater, apparently, is going to be marked down 30%, whereas the jeans are going to be marked down 15%. So we have two items being reduced in two different ways. And then on top of that, we have a sales tax being added after these first discounts are taken. So let's go ahead and create our bar diagrams. I'll do them both kind of simultaneously at the same time, since we already know our information given from the problem. At least I hope you know your information by now. We know that we're measuring everything in money for this problem. And we'll go ahead and label now. This will be the sweater. This will be the jeans side. So I'll use S and J. 100% of the sweater's cost is $35. So that's going to be up here on the top. 100% of the jeans is $28. That's how much they cost full price. We are taking discounts. We know, for example, that we are taking a 30% discount, which means the percent's dropping by 30%. I am just approximating where I think it goes. I am actually not taking any real measurements. So, 30% drop. That's what's happening there. If I had 100% and I dropped 30%, that takes me down to 70%. But I don't know what the new sale price is for that sweater. Over here on the jeans side, I only dropped down 15%. So we know we're going down 15%. Well, if I was at 100% and I dropped down 15%, I am now at 85%. What I don't know is the new sale price over here for the new pair of jeans. But the process is exactly the same as I did in previous problems. I'm going to go ahead and quickly set up my proportions, and I'm going to leave off units for now because we understand that they are there, but sometimes they tend to get in the way when we're trying to do a lot of math. So on the left hand side, I'm going to have 100 over 70 equals 35 over x. On the right hand side, I will have 100 over 85, because that's the new percentage, equals 28 over x. For both, I will cross multiply. I always like to start from the bottom left to the top right. Students often ask if it really matters, and it doesn't, but I like to be consistent. So I like to go from bottom left to top right, and then I'd like to go from the top left to the bottom right. And I'll do the same exact thing over here on the other side. So I have 85 times 28. It's very important to keep your work organized, and you're going to find that out really soon with this problem, if you didn't know that already. Equals 100 times x. Alright, so let's go ahead and work out this math. I have 70 times 35, which I did in advance, and that's 2,450, equals 100x. And over here I have 85 times 28, which equals 2,380. And that equals the other side, 100x. Same exact process I've done before. I'm going to divide both sides of my equation by whatever number is with x. In this case, that's 100. It's quite often the case, but not always. You can have different numbers you're dividing by. It won't always be 100, so make sure you don't get too used to that. But it is very nice when we do, because we have nice cancellations, and all we have is a simple decimal movement. 100 divided by 100 is 1x. And then we have 24.50 divided by 100 is $24.50 in this case. That's the sale price of the sweater. Over here, we have 100 divided by 100 is 1x. And then we have 23.80 divided by 100 is $23.80. And that's the sale price of the sweater. But both of them are being bought at the same time. So that means both of them will be added together. I will add the $24.50 plus the $23.80 to get a total price. And in retail or in shopping, the total price before taxes added is called the subtotal. So you may want to make a little note of that over here on the side, because you're going to see that word sometimes on tests. It means the price you pay before tax is taken. And when we add those two numbers up, we get $48.30. That's just our subtotal. We still have to add tax. So one more time, I'm going to make a final percent bar, I hope, for this problem. Well, not I hope, I know. And I'll make it over here on the left so we can work on the right. Whew, seems like an awful lot of work. But if you get this done right, there's nothing you can't handle with these kind of problems. So, as always, 0% to 100%. Then we have $0. Our new subtotal is $48.30. Previously I mentioned, with tax causes the price of things to go up. And in this case, we have to go back to our problem, and it says we are adding a sales tax of 8%. So we're increasing our percentage by 8%. Well, if we go up 8%, I'll make my arrow a little more bigger. There we go. Up 8%. That means we are now at not just 100, but 108 more, which is 108%. We don't, however, know how much that new total cost is going to be with tax added, but we can see our proportions already being set up. So let's go ahead and get right to it. 108 over 100 equals x over 4830. Let's go ahead and cross multiply. 100x equals, and I'm going to multiply for you guys this part already, the 108 times 48.3, and that is 5,216.4. We're going to divide both sides by 100, and we get 1x. So I'll bring my work over here to the right hand side. A single x. My decimal member, because I'm dividing by 100, moves twice to the left. 1, 2, and I get 52 or 52.164. We are, however, talking about money, so money only goes two decimal places. So it's going to go, here's my dividing line that breaks it up. The 4 is not big enough to affect this 6, so I can go ahead and just cut it off without any changes. And my final answer is x equals, or excuse me, my final cost for everything, the total cost is $52.16. And we see that to be choice D. That was a lot of work for one problem. This is why it's very important to stay organized and not to always rely on everything to be done in your head, which we all know we've all been guilty of sometime in our lives, right? Right. So that was number 6. Let's go ahead now and we're going to move on to number 7. So let me throw that back up on the screen for you. Number 7. Looking at the graphic, I remember this has to do with popcorn. I mean, not popcorn, with the movies, the movie theater. So this is something that you're going to see quite a bit happening in your life. The price of a movie ticket was $6.75 in 2010. Seems just like yesterday I can remember dollar movies. Now it says and $8 in 2013. Well, that's almost 3 years ago, and I'm sure they cost more than that now. Find the approximate percent increase in the price of the ticket. So now we want to know what percent is something increasing by. Up until now, all our examples have been changes in money and finding the new dollar amount for things we buy. But now we're going to figure out the percent. So this is a new type of problem, but it's handled the exact same way, as you shall see really quick. So as always, let's get our percent bar ready. This is a very simple problem, shouldn't take too long. It's actually kind of like problem number 1 in the very beginning. And if you got that one, then this one you'll see will be really easy for you to tackle. Okay, so as always, we have from 0% to 100%. And since we're talking still about money, we're going to have $0. Now, let's go ahead and look at what's going on. We have two prices being given to us. So you may wonder, well, which one's considered to be full price? Because in 2010, the full price was $6.75. And in 2013, the full price was $8. But we're looking at change. So we want to know what was the first amount that we had. That's going to be considered our original, or our 100%. So our original amount was $6.75. All right, we can live with that. That's 2010, good times. Now we have a change happening. Now, price is going from $6.75 to $8, so we are seeing an increase. So I'm going to go ahead and just add, I guess, like a little box up here to represent that increase. I don't know how much I'm increasing by because that's the whole point of the problem, but I do know that the new price after this mysterious percentage increase was $8. But I don't know my new percent, so I'm going to call that X. But once again, I can still already visualize my whole proportion. So I'm going to figure out what is my mystery percent over here. So let's make the proportion. X over 100. Doesn't really matter where the X is. 8 over 6.75. $8 over $6.75. We have percents over here. Same exact process as we have done previously. Cross multiply. 100 times 8 equals X times 6.75. Now let's see who's paying attention. We know that 100 times 8, well, that's easy, duh. That's going to be 800. But on the right-hand side, look what we have. We have X times 6.75. If you're paying attention, then learn this rule right now. When you multiply a variable times a number, that we formally always write it with the number first, 675, and the variable second, X. So make sure you change it around like that. I know technically it won't really affect anything, but it's just more algebraic and more proper. And it is what you're going to be doing in the future, so you might as well get used to it now. Now, I also told you previously that we're not always dividing by 100. And this is one of those situations where that happens. This tells me that 6.75 times X equals 800. But I don't care what 6.75 X's is. I want to know what is just a single X. So like before, I will divide by the number that is with the X, which is 6.75. But whatever I do on one side of my equation, I have to do to the other side. Now the math is easy on the right. 6.75 divided by 6.75 goes into itself one whole time. So I have a whole X left over. Now I have 800 divided by 6.75. When I do that math, I get this long decimal that goes 118.518, and those three numbers keep repeating over and over and over again. Now, I'm going to go ahead and, since we're talking about percents and not money, there is no rule where how far percents go. So I'm going to go ahead and, looking at my answers here, all the percents just go to one decimal place. So I'm going to go ahead and just go to one decimal place. I'll draw my line right there, and I see that this 1 is too small to affect the 5, so I'll just cut everything off. Nothing's going to change. And now I know that my new percent up here is 118.5%. Well, that's great. That's my new percent. Let me go ahead and make it a little more bold so it stands out some more. That's all fine and dandy. But the question is, what is the approximate percent increase? How much did it go up? Well, if I was at 100 and now I'm at 118.5, I had an increase of 18.5%. It's just the difference you subtract. And that is also the same choice I have for A up there. So I know my math worked out pretty good. I would hope so, considering I'm the teacher. But this is not math you can't handle either. So that was number 7. If you have any questions about that one, like always, stop the video, raise your hand. So there are some more task cards there, and I'm going to do one last example for you, and that's this next one, number 8. Number 8 is very similar to the one that we just did. And it says the high temperature was 80 degrees on Saturday, but only 56 degrees on Sunday. Find the percent decrease in temperature. So we're going to go ahead and do the same thing all over again. Here we go. Let's make it quick. I would imagine by this time you guys would be pretty fast. So if you think you know this pretty well, why don't you try racing me and making the bar diagram, setting up the proportion, and getting it even solved before I do. Because I already have my multiplication done. So let's see how good you really are. If not, you can stay with me still. and just follow along to make sure that you're doing the steps the same exact way. Now, in this situation, we're not dealing with money, we're dealing with temperature. So 0%, well, I guess we'll go ahead and say that would be 0 degrees, although you can have less than that in real life. 100%, we have two temperatures again. But just like in the last problem, when we want to measure percent of change, either increase or decrease, you start off with the one you had first. And we were originally at 80 degrees. So that's what we're going to call 100%, 80 degrees. That was Saturday, but on Sunday it was 56 degrees. So now we know that it dropped some mystery amount. We don't know how much, but we know it just fell. We don't know the exact percent yet, but we do know the new temperature was 56 degrees. So I'm going to go ahead and find that new percent so I can actually figure out how much it dropped by percentage-wise. Here's my proportion, pretty much set up already, 100% over x%. Notice the x is on the bottom this time. Like I said before, it don't matter as long as you keep everything lined up. 80 degrees over 56 degrees. We're going to go ahead now and cross multiply. X times 80 on the left equals 100 times 56 on the right. I like putting everything in parentheses. It keeps everything orderly. X times 80. If you remember the rule from the last problem, we rewrite it as 80x. 100 times 56. Since I'm multiplying times 100, my decimal, instead of moving into the left when I divide, will now go to the right 2 times, which leaves me 5,600. Now, I don't want x. I want to get x all by itself. I don't want 80 of them. So I will divide all 80 of them by 80 so I can get the answer for just one single x. 5,600 divided by 80 gives us an answer of 70. So my new percent is 70%. But notice none of those are up here. That's because we're not measuring what's the new percent. We want to know what was the percent of change. In this case, the percent decrease. Well, to go from 100 to 70, you had to decrease or go down by 30%. And that would be choice E. You now have sufficient examples to do all these problems. Good luck, and if you have any questions, make sure that you word your question carefully and then go ahead and ask whoever's here to help you in the room. Good luck, guys.